Hello everyone. Today we are solving another LeetCode question, question number 559. We have to find the maximum depth of N-ary tree. We have solved similar question for the binary trees where we have to find the depth of the tree. There the question is very easy because we have to compare the depth for the two of childs, but now they are the N-ary. Still the question comes in very easy category. Let's try to understand how we are going to solve it on a whiteboard. So first take the root node. This is the root node. For any root node, what exactly we have to do? So out of n child, recursively find the depth of this, find the recursive depth of this, find the recursive depth of it. Okay, for this it will say the depth is 1, this will say depth is 1 because this is a single node, they're not for the child. But this node itself to find the depth of it, eventually it will find 1, eventually it will find 1. So the maximum out of these is 1 plus it will add its own. So eventually it has the depth 2. Now for this root node, what it exactly does for all my childs, give the maximum depth. So 1, 1 and a 2, eventually it will say that 2 is the maximum depth for all my child plus I will add my own depth. So 2 plus 1 is equal to 3. So the maximum depth for this node is 3. Now let's consider for this as well. So for this, when you are going to solve the depth for this node, what it says, add 1 for myself plus the maximum depth of all my child, out of which one has the depth, so calculate for depth for each one and whatever has the maximum for children और यहाँ पे depth of children. So you have to find the maximum depth of the children and then eventually add 1 for that will be your answer. And the same concept you are applying for every single node. So let's say this is eventually have the 1, this will have this go on all the possible path for 1, 2, 3, and 4. This will eventually lead you the 4 answer, this will lead 3, and this will also lead the 3. So what is the maximum out of all the children? Answer is 4. And plus it will add 1 for itself. So eventually for this tree, the answer is 5. Now we just have to implement this and code. Let's write the code. So first thing always we have to write is the base case whenever we solve a problem with the recursion. So what we have to do is check root is equal to null. At that case, what we use say is return 0. Then otherwise you have to solve the problem with the recursion. So in max step, so this max step I'm solving for my children. So eventually I will say that for all my children this 0. Then you try to iterate over those child. You say okay, this is 3 node child out of dot children. You now set the max depth is equal to max dot max. If any of the child has the maximum depth, then any of this, what the value I'm currently storing, I'm keep on updating those values. You can individually calculate, store it somewhere, and then eventually find the maximum out of it. But during while the computation itself, if you compute the maximum value, you don't have to wait the storage time. Okay, so what is the here we are saying first argument is always max depth and the second is max depth recursively calling this function for my children's. So I will call this function for child and it eventually returns the maximum depth. Final one for the root node and whatever I get from my child, the maximum value out of it is max depth. So this is the simplest implementation we have to do for this question. Let's try to run this. Okay, we missed something here. It said that root does not have an argument as children, but okay, root cannot be converted into tree node. So it says that yeah, instead of tree node, it is a node itself. So let's try to run it again. Okay, so now all the test cases passed. Now we try to submit this. So we are able to run it in 0 milliseconds and yeah, almost beating 100%. Now, what is the time complexity for this algorithm? Eventually, you are visiting every single node. So the overall time complexity of this algorithm is the order of n. So thank you for watching this video. I will come up with the more questions. Thank you.